So let's give it a try here. It says use the trapezoidal rule to approximate the integral for n equals 4 and n equals 8. So here we have the definite integral from 0 to pi of sine x dx. And we want to use the trapezoidal rule to do this. So if we wanted to split this up into 4 equal intervals, we can see they're kind of made for us very nicely here. And so I have 1, 2, 3, 4 intervals. And we're going to use the trapezoidal rule, so let's go ahead and draw trapezoids. And you can see it's so close to the approximation that you can barely even distinguish the line from your function. Okay, so that is going to be our intervals. Okay, so before we use the trapezoidal rule here, let's go ahead and determine what the x values are for all of our intervals. So obviously it starts with 0, and we have n equals 4, so that means our delta x is going to be pi minus 0 over 4, or pi over 4. So each one of these is going to increase by pi over 4. So this one here is at pi over 4. If we add another pi over 4, we're at pi over 2. If we add another pi over 4, we're at 3 pi over 4. And then finally, we end here at pi. Okay, now let's go ahead and apply our trapezoidal rule since we have all of our intervals marked out. So we need b minus a over 2n. So b minus a is just pi minus 0, and then over 2n, which would be 2 times 4. Now you can also think of this as 1/2 times delta x. Gives you the same thing. Okay, and so this is going to be times f of x sub 0. So that's just going to be sine of 0 plus 2 f of x sub 1. So 2 sine of pi over 4 plus, well, we continue with 2 until we get to the very end. So 2 sine of pi over 2, okay, plus 2 sine of 3 pi over 4, right there, second to last interval. And then our very last one is pi, so now we only have one of those. So it's just going to be sine of pi. Okay, so let's go ahead and simplify all this to find our approximation. So this ends up being pi over 8. Sine of 0 is 0 plus 2. Let's see, sine of pi over 4. You can pull out those unit circles again. So we get root 2 over 2. And then plus 2 sine of pi over 2, which is just 1. And then plus 2 times sine of 3 pi over 4. So that's another root 2 over 2. And then plus sine of pi, which is 0. Okay, so we get pi over 8 times, well, let's add all this up. So these 2's will cancel here as well as here. So it looks like we have 0 plus root 2 plus 2 plus root 2 plus 0. So that is going to be 2 root 2 plus 2. And if we calculate this out, we get about 1.896. Okay, so there is our approximation using 4 trapezoids. All right, let's try it now again with using 8 trapezoids. So we'll keep our original 4, and then if we want 8, we want to go halfway in between there. Okay, so now we have 8 subintervals. And let's figure out what they would be on here. So we just need to take all of these and divide them into half, really. So we're going from 0. This one would be pi over 8. This one would be pi over 4. This one would be 3 pi over 8. This one becomes pi over 2. This one becomes 5 pi over 8. This one here is 3 pi over 4. This one is 7 pi over 8. And finally ending with pi. Okay, so let's go ahead and come up with our approximation now. We're going to have a lot more things to add here. So we're going to get pi minus 0 over 2 times the number of rectangles. So it's going to be pi minus 0, which is just pi, over 2 times 8, which is just 16. And then we're going to follow this pattern right in here, coefficient pattern, 1, 2, 2, 2, 1, using all of our x values in here. So we're going to get sine of 0 plus 2 sine of pi over 8 plus 2 sine of pi over 4 plus 2 sine of 3 pi over 8 plus 2 sine of pi over 2 plus 2 sine of 5 pi over 8 plus 2 sine of 3 pi over 4 plus 2 sine of 7 pi over 8 plus, well, this is our last one, so it's just 1 sine of pi. Okay, so looking at all this, since we're getting an approximation anyway, there's no real need to find your exact answer for this. So you could type all of this into your calculator and we would come up with an approximation of 1.974. Okay, so as we increase the number of trapezoids, which we didn't draw in here, as we increase the number of trapezoids, they more and more closely resemble this curve. And so as we increase them, we get a more accurate answer for our definite integral. And let me show you what I mean by that. So if we were going to take the definite integral from 0 to pi of sine x dx, we would actually never use the trapezoidal rule because we know the elementary function that has an antiderivative. So the antiderivative of sine x is negative cosine x, and we would evaluate that from 0 to pi. So the fundamental theorem of calculus says negative cosine of pi minus negative cosine of 0. And so here, let's see, cosine of pi is negative 1, so negative of negative 1 gives me positive 1. And then cosine of 0 is 1, so minus a negative 1 is plus another 1, and it equals 2. So we know the exact answer is 2, and look at this. The 1.896, the 1.974, as you increase the number of trapezoids, we're going to get closer and closer to our true value of 2. So let's take a look at our next example. Because this one, we don't know the elementary function for, and we wouldn't even be able to use u substitution to find it. So for this example, the trapezoidal rule is going to be a good approximation, and I want you to give this a try by approximating this for n equals 4, meaning 4 trapezoids, and n equals 8 for 8 trapezoids. So give this one a try on your own, and then come on back to check your work. Alright, welcome back. So splitting this into 4 rectangles, you should have gotten a delta x of 1/4, and you can draw your trapezoids here and label your x values. And so if we get b minus a over 2n, we get 1/8, and then just substitute in all of your x values here. Notice the coefficient of 1 and then of 2 all the way until 1 at the end. And we're always going to round these to the nearest thousandths place, so you get 0.797. When we increase this, the number of trapezoids to 8, our delta x becomes 1/8, and you can see we just fit in an extra one in between there, and then we label all these down below. And if we write out the entire trapezoid rule, we just need to substitute in 0, 1/8, 1/4, all the way on. Notice again that it goes 1 and then 2 all the way down to 1 at the end. And now our b minus a over 2n is 1/16. Okay, and a more accurate answer of 0.826. Alright, so this process can be a little bit tedious, but writing it all out and using your calculator, you should be able to come up with the correct approximations.